Hello there. Today we'll be doing kth largest element in the array. I think you already know what we're doing based on our previous video. This is our 68th video of the 150 Neetcode videos. Let's get it. So in this particular one, we are looking for the kth largest element. A simple way to do this is to sort the items and then get the kth item if we sort in reverse. Or we can get the length of the item minus k and then sort it in regular order from lowest to highest. That would be n log n. But we can do this better by doing a heapify method, and we could do k log n. So the most what I found the way to do that is using a heapify max. This is a max heap. And then we do the same thing we did earlier previously, and we set the results equals to heap q dot heap pop of a max. So this is the max method of getting the nums, and we k minus equals 1, and we can return the results after it exhausts all the k's. So this would be k log n plus n for heapifying. So the overall time complexity is k and log n. But there is a lot faster average times according to Neetcode's videos, and it's called quick select. It is a very interesting method where basically we pick one item and we sort one item at that particular time. And then after sorting that one item, then we know whether it's greater or less than the k than that particular item, and basically with that we could split it in half, hopefully, and on average we can get it in the kth time after the kth search. But unfortunately, sometimes if you the worst time scenario is if you pick a particular point where you select the greatest item and you're not cutting anything in half, and so you're doing a n squared approach. So why is it n squared? The reason because is that when we do when we find that one point for one variable, I have to search all the other variables to make sure they're in the right placement so that you can get into the right placement. And so let's get the problem, let's get it, and you can see more clearly after we type out the code. K equals length, so that's the number item that we want to get, minus k. And we're going to do a quick select now. And L and R. So we're going to get a pointer and a pivot value. And we're going to set that equal to nums at r. So why L? We're going to set it at the beginning of our number of items so that we can go through all those items to get to and search L through R. That's our pointer. Everything that's less than our pivot point is going to into the pointer value, so that we can get a stack of a whole bunch of values that is going to be smaller than our pivot point. And so for I in range of L and R, so for the entire range, if nums I, this is where the n time takes. Well, yeah. Anyways, you will wonder why this is O of n. It's because n plus n divided by 2 and plus n divided by 4 and so on and so forth is eventually equal to 2n, and that is basically O of n on average. When we're able to cut it in half. But cutting in half, isn't that log n? Weird. Anyways, we got the pointer, and we gotta move the I value if it's less than the pointer and move it into the pointer value every single time. If it is greater, we just leave it there. And then eventually we'll move all the items that are smaller into the pointer before the pivot value, and everything that's greater is going to be after a pivot value. So then once we're done, we're going to move that pivot value, the pointer, to and our pivot value. With that, we are now complete our picture, and let's check if our value is equal, greater than. If it is greater than, we're gonna go check the left side. If it is less than, then we're going to check the right side. So if our pointer is greater than k, so our pointer is more than what we wanted, so we want to check the other side to see if we can get find our value there. So what's happening here is that we're going to return the quick select of the left side. So this is pointer -1. Else if pointer is less than k, so return quick select. So the pointer is now less than k, is on the left side of k. So we need to get bigger, a bigger pointer. So we're going to go to the right. So that means PTR +1, and we're going to go to the right. Else, we found it, return the pivot value. Then the last thing to do is return quick select of 0 and the length of nums -1. With that, I think this should work. Oh, it does not work. What the heck happened? Not sure. Let's take a look. Why would it give us 6? I don't see anything right now. So yeah. I really don't see anything. I mean, the only difference between my usual code and this code is this particular point here. Oh, I see. Oh, still wrong. I don't know what's wrong. I don't know what's wrong. What is up with that? That is very interesting. What happened there? So we accidentally gave out the wrong spot, which is nums are, which is not what we wanted. We the pivot value was not what we wanted. We wanted the pointer. The pointer was the point where we found cave. But for some reason, if we set the pivot value here, it does not swap properly. It does not swap properly. That's the problem. Interesting. So I think if we want to do this more clearly, and we don't want this mistake to happen again, we'll take out the pivot value. And then just pivot, make comment is at R. And instead of this, we do nums at R. And we do run. This should work. Oh, that's not how you make a comment, right? My bad. Okay, run it again. All right, very good. I think this code is a little bit cleaner. That way, we're making this a little bit more clear about what's going on. The pivot value, that just makes it more confusing, because you'd think you would be able to move the pivot value here. Of course, we're pointing at a particular value in the array. I think it's better if we just hold the pivot value at R. And so swap pointer and pivot. Yeah, I think that's better to leave a comment there. So it's easier for us to remember what's going on, and instead of doing a pivot value there. But with that, I think we have solved the problem. I think we have a pretty good solution here, and we solved it two ways: one, k n log n, and this here is an average of O of n. Well, thank you very much. See you in the next one. If you have any questions, please comment below. If you enjoyed the video, like and subscribe.